or a centralized D-level maintenance support at the BRD. Well, amongst all these, my key interest is the upgrade, because this upgrade has a dynamic effect on the life cycle. I'll explain. This is the classical bathtub curve. We all are familiar with this, where it depicts the infant mortality during the initial phase of the equipment when it is inducted or developed. After the normal life, where it gives us a usable life with low failure rate, during the end, because of wear out, the failure again increases. But with a midlife upgrade, we can actually push this curve to allow the equipment to serve us for a longer period. All midlife upgrades, like the Indian Air Force did with AN-32s, with MiG-21s, with MiG-29s, Jaguars, Mi-17 helicopters, and so on. We have actually pushed the life to serve us for extended periods. Modern life cycle supports like predictive diagnostics, which includes systems like tools like HUMS, and high fidelity testing, they enable us to go deeper and understand the failures way before it actually creeps in. Performance-based logistics, very well-known terminology and very profound business strategy by giants like Boeing, Lockheed Martin, Airbus, and various other aviation industries. This is adopted to ensure high serviceability or high availability of platforms at all times. When we discuss about these modern life cycle supports or the conventional life cycle supports, we must consider the economics of it, where we see, and when we analyze the total cost of ownership, it is very, very clear that the cost of the equipment, which is close around 20%, the rest of the 80% goes into the maintenance of it, or sustaining that platform for these many years where we are intending to utilize it. It includes maintenance, it includes spares, it includes resources, and whatnot. At the same time, if these equipment are bought out from foreign OEM, we will not be able to stop the foreign exchange outflow, where we are buying spares at escalated cost every year, and the supply chain's resilience due to geopolitical effect and the obsolescence of technology. The technology which are being provided to countries like us are not the top notch. It may be the level 2 or level 3 level of technologies. Because of this, these technologies hit obsolescence faster. So how do we mitigate it? One of the proven tool is indigenization, where we all are aware how indigenization can contribute, but I would also like to bring out a different perspective towards indigenization. We all think that indigenization is only a reverse engineering. Well, it is much more than that. Indigenization is not restricted to reverse engineering, rather it has now crept in more better methods like re-engineering through a black box approach. This helps us building our own technology and without infringing into any IP. In many cases, where we have developed indigenous repair technology in upfront, this repair technology has helped us in developing that entire technology or entire equipment. In last 3 years of my of my posting in BRD, I have seen where we have started the project as repair, and eventually we are successfully developing that product, that equipment, and successfully trying it for flight trials. At the same time, when we develop a test equipment for any equipment, these test equipment gives us vital parameters. These parameters are again essential to help us re-engineer that equipment. So, well, we should not think indigenization as only reverse engineering. We must improvise or utilize this platform for re-engineering, developing repair technology, developing equipment and its test equipment, so that this cycle can be iterated and we can develop better equipment, better replaceable equipment. So what is the effect of indigenization? Indigenization can easily bring down the total cost of ownership. It can bring down the foreign exchange outflow significantly, and it can reduce the dependence on any supply chain issues or obsolescence issues. There are few challenges posed by modern warfare. One of them is rapidly evolving technology, where we are very comfortable in pushing a midlife upgrade, and suddenly, because the technology has become obsolete, all our investment goes down the drain, because that equipment is no longer practical or usable in the modern warfare. This challenge forces us to adopt a different technology which comes at a higher cost. The next challenge is to choose between cost, reusability, and efficacy. These three sides of the triangle are not very simple, but very complex. The choice between these three decides where we are supposed to invest, what equipment to choose, whether this will perform in the warfare or not. Few solutions which I would like to propose is modular open source architecture. This is a proven architecture. Many of the Western world has already adopted this. We have also adopted this in many fields where only specific modules are developed which can be reused for multiple applications. It is like Lego blocks. These blocks can be rearranged to develop or define a different set of equipment. I would also like to give you a simple example. In last 10 years, the way SBCs have developed, the single board computers have developed. These SBCs comes at various form factors. One single board computer can be programmed to work as multiple applications, wherein the internal hardware architecture remains the same. 20 years back, the percentage of hardware and software used to be close to around 50% hardware and 50% software. Nowadays, the dependency on hardware has reduced. The IP is now lies in software. The balance has shifted to 20% to 20:80. 20% is hardware and 80% is the software, the algorithms which runs that hardware. So having a modular open source architecture can help us in iterating fast, in developing any technology at a faster pace, and shifting from one technology to other at a rapid pace. approach which I would like to tell you is implementing a maintainability at the stage of inception. Well, maintainability should not be an afterthought. It has to be implemented right from the drawing board. Then only you will be able to support during the life cycle. And the third and the most important is standardizing the design. Well, universal serial bus or type C connectors, these are not simple examples, these are inspirations for the entire industry. How a simple standardization can transform the complete use of technology.
Yashahu?
When we talk about life cycle support, only one tool is not enough. We really need a toolkit. And sometimes few power tools like indigenization and modular open architecture into that toolkit. This will help us in sustaining for long. Thank you very much. Thanks for time.
Thank you, Vingamana Shahu. Please join up the panel. Thank you very much, and we are taking the industry input hereafter. I'll request Shri Lokesh Joshi to come up and appraise us about the advanced materials for aerial platforms, land systems, and wearables.
Next to that. Don't change kara to इससे next to
Thank you for the opportunity. It is an honor to be presenting here, and I observed the great collection of the speakers, and striking observation is that I am the least educated and the youngest organization present here. So please bear with us. So we are Grow Culp S2CNT. So GRO is from growth, Culp is Brahma's one day. So Grow Culp, you are growing forever with us. We focus on developing advanced materials, advanced systems, completely made in India, the whole supply chain in India. If equipments are not there, we design our own equipments. We are heavily supported by government. We got a lot of funds from them to develop these solutions. It will be highly technical, so if you are getting bored, you please let me know. So there are three critical elements what we will discuss